Look at that. My name's Martin Beeby, and I fail at technology there. Sorry about that. I work for AWS. My name is Martin Beeby. If you're on Twitter, please do add me on Twitter. I'm at the Beebs. This is an important slide in my talk. If anyone's got a camera phone, please do take a picture of this right now and send it to me on Twitter or LinkedIn or somewhere. Someone in this room, please take a picture. Thank you, sir, for taking a picture. The reason why this slide is important to me is it's my inception slide. You'll see that I'm standing in front of a slide of me pointing at a slide, me standing in front of a slide, of me in front of a slide, in front of a slide, in front of a slide. I'm currently 19 layers deep. I've attempted to do this in every talk that I've done over the last year. There's some times that I've got it wrong, or someone hasn't taken a picture, or someone hasn't sent it to me, but I'm about 17, a chain of 17 inceptions. So it's an important part for me. I'm a software developer. I've been a software developer on the .NET stack since I was 16 years old. And I've been developing now for 21 years as of yesterday, because it was my birthday. And I'll do the maths there. My birthday yesterday, that makes me 21 years old. Yeah. And I work at Amazon Web Services. I've been working there now for about 7 months. I'm brand new to AWS in terms of using it. I'm not a long-term AWS user. I don't know how I got the job, really. I don't know why they hired me. They wanted me to be an actual evangelist for .NET. So they wanted people which are doing .NET or Windows workloads on AWS, someone which can explain it to them. So they thought they'd hire someone like me, who has a ton of experience on Azure and Red Dog and Oracle Cloud Infrastructure, but no experience on AWS, to try and explain that to people. And so over the last sort of 6 months, I've been learning as much as I can about AWS, and then going around the world and speaking to .NET developers, explaining how they can also build stuff on AWS. Now, PowerShell usually isn't really my central focus. So I'm not necessarily a operations guy or a PowerShell person or an ops guy, really. I use PowerShell a lot, like as every Windows developer probably has done. But this talk was originally going to be given by one of my colleagues, Steve Roberts, who is the lead dev on this. But he actually got his holiday incorrectly set up. So he's actually halfway up Mount Everest at the moment. Luckily, he's not going all the way to the top. So, but he's in Tibet at the moment, and he asked me if I could cover this. And it's an area that I've taken a lot of interest in, because PowerShell is a really powerful way to control and create AWS infrastructure. So I stepped in and said that I'd happily take over the session and relieve Steve from his duty so that he can be in Tibet. And but this is fundamentally his session, right? So I've just learned this session. I'm going to be playing it to you guys. And hopefully, in the learning process of it, I've come at this brand new, whereas Steve has been developing the PowerShell tool since 2012. And so, I come from it new, not only to the PowerShell tools on AWS, but also to AWS generally. And how many people use AWS here in their day job? Very few. That's good. I'm in the right room, right? So I think I'll take a sort of a little look about what AWS is generally as well, and then we'll look at the PowerShell tooling and how we create and manage infrastructure in AWS. And I'll take it that, because I was only like one person, either you're all embarrassed to be working on AWS or there's not much AWS experience, so I'll try not to use too many acronyms which don't make sense and things like that. So the things that I'm going to be looking at is a brief overview of AWS, a look at what PowerShell at AWS is and what that means, how you can find your way around those PowerShell tools, PowerShell with AWS Systems Manager, DCS with AWS System Manager, so how you can do a design state configuration, and then finally we're going to look at PowerShell and looking at serverless PowerShell. So how you build PowerShell and serverless scripts and then deploy them to our service in AWS, which is called Lambda, for doing stuff. How many people have done Azure stuff or know Azure as a context? There's a few. Okay, cool. So AWS as a cloud platform is the broadest of all the cloud platforms. We have more services than anyone else. We have more global footprint than anybody else. It was one stage we just had instances, yeah? So you'd have a new instance or a new virtual machine in the cloud. You'd provision it, you'd manage all the network. But what we do at AWS is that we build that foundational infrastructure, and then we go to our customers and we find out what they're doing with it. And then we find ways that we can improve our service offerings. So it's all based upon like what customers are asking us for and what they're doing. And also one of our biggest customers at AWS is Amazon.com. And so a lot of the feedback we get from Amazon.com, we go and create higher level services inside of AWS. So not only can you create virtual machines and networking and doing all that sort of stuff, you can also now, have a relational database service, which is a managed version of SQL Server in the cloud. And we manage it all. We create the infrastructure, we create the SQL servers, we put it in availability zones, we do the high availability for you, and you just get a database server that you can install 100 databases on. So we have lots of high-level services. And the reason we created that high-level service was because customers were saying, we would like someone else to manage the SQL side of things, and we'll just give us just a service. Or we've recently added an Active Directory service, so you can have Active Directory managed in the cloud. Or we have a blockchain service, because everyone's got a blockchain service at the moment. And machine learning, artificial intelligence services. So if you want to add artificial intelligence into applications or to use it to do process automation or things like that, we have a really deep array of machine learning and AI services. We have 11 different types of database we support at AWS. We have tons of different ways of storing information, block, blah, 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 blah. DevOps systems, IoT systems, analytics, the list goes on. Over 165 services, and that was like 2 months ago, so there's probably more since I've done that last count. And it's compute, storage, relational, non-relational databases, analytics, everything which AWS do. And we do it in a really global way. We have we have regions all over the world. Each one of these markers is a region in the world. And a region consists of a set of what we call availability zones. Each region has 3 availability zones. And each availability zone is made up of 1 or more data centers. So a lot of people make the mistake of saying, oh, you've got a data center in Sydney. We don't have a data center in Sydney. We have many data centers in Sydney. We have at least 3 availability zones and at least 1 data center in each of those availability zones. An availability zone, by the way, is a term that they use at AWS, which means inside a region, you have completely separated infrastructure, completely separated data centers. And they're actually separated by a number of miles. So we have each availability zone is geographically located so that it's far enough away that if a natural disaster was to strike one of those availability zones, the other ones would still be there, but not too far away that the latency would be too high. So we have a sweet spot for building our availability zones, and that's part of our unique offering. We're the only cloud provider which offers that level of resiliency with availability zones. If you're interested in how we build this thing, there's a website called infrastructure.aws, which goes into explaining what regions are, what availability zones are, how we connect with points of presence, what our network's made of, how the fiber works. We have tons of talks at reInvent about exactly how we put all of our operations forward. This is Frankfurt Frankfurt region. You'll see that the yellow block is the region, and then there's 4 dots, in Frankfurt. They're the 3 availability zones. And and Frankfurt is completely separate, obviously, from Stockholm, is completely separate from Milan, is completely separate from London. If you deployed an application into Frankfurt, it wouldn't accidentally end up in another data center. For obvious reasons, we ensure that all of your data remains within the region that you deploy your application to. So lots of people will deploy applications to a region, and they will deploy this application to multiple availability zones, so that if one availability zone falls over, they have the other 2. So you'll hear that terminology, regions, availability zones, and data centers. And if we're building resilient, high available apps and resilient applications, then we'll probably want to span multiple availability zones. We might even want to get into the world of multi-region support as well. And customers, some of our customers like Netflix, obviously do multi-region because their customers are global, but they're also doing multi-availability zone as well. So infrastructure.aws is a great resource to learn a little bit more about that. The other big difference between AWS, let's say, and other providers our cloud providers, is that we're constantly looking for ways that we can shave milliseconds off the network performance. And we're constantly figuring out ways that we can get the right size machines in our data centers. And we're constantly thinking about simple ways that we can increase our capacity and reduce our costs and pass that on to our customers. It's a very competitive market, cloud computing. And so any kind of performance gain that we can have, we will reduce our costs, we can pass that on to customers, and we can be more and more competitive. There is a bit of an arms race between cloud providers to make sure that we're constantly getting better and better services, which are more globally distributed at a lower and lower cost. So, for example, this is one thing that we've done last year, which is on the left-hand side is our fiber, one of our fiber cables, which connects our data centers to one another. And you'll see in that conduit, in that space, there were 3,456 fibers in that conduit. On the right-hand side, we've got another cable. It now contains 6,912 fibers in exactly the same space. And that's important because it means that we can run that cable without having to drill new holes, drill new trenches for those cables. And we can double the capacity of the fiber just by making that one innovation. So by looking at the really small details, like the cables that we use, and actually working with partners to create new types of cables with more fibers and do lots of different clever things to increase our productivity, we get more and more efficient. We're able to reduce our costs. We're able to produce a cloud platform that truly scales, is truly highly resilient. We're the leading cloud platform in terms of staying up and being on and being online. And so, and all of that's about the small details that we really sweat over to make sure that you as operations people or developers are able to deploy your applications and know that we will remain online and your applications will remain available to your customers. If you're a developer or if you're a user of AWS services, there's a number of ways you can interact with it. And there's some terminology here as well. You'll hear people say the console, AWS console. This is what they mean. This is the AWS console. It's the AWS website in my vernacular, but they call it the console. And it basically is the website where you go, where you can manage all of the different services, you can look at all the different services, and you can create all of the different services. So I could do a search for EC2, which is Elastic Compute, and we can go into the console for EC2, and we could add instances, we could deploy virtual machines directly from within there. This is the console for Lambda. So when we're deploying serverless functions, we use a service called Lambda, AWS Lambda. And this is the console where you can go in and you can point and click, and you can upload files, and you can connect it to Git, and you can deploy things and do it all through this console. And lots of people do just that. They work directly from in the website to deploy their applications. But obviously, most people would probably want to start scripting against it. We built a command line interface very early on. It's actually written in Python. It's called the AWS CLI. And this allows you to create in Bash, at Bash, AWS infrastructure. Interact with the services, work with the different services, query the infrastructure, and do various different things. Now, we've had a CLI for a long time, but people wanted higher level abstractions on that. And so if you were doing in the CLI and we were just, on a Mac, and we were just sort of, AWS is the command line interface, S3, I'm basically creating a bucket there, make bucket, S3, giving it an S3 name, putting it in a specific region, and that will create me a bucket on S3 from the command line interface. We also have a toolkit for Visual Studio Code. You can install that, it's a plugin. It enables you then to, inside Visual Studio Code, the editor, access some of the services, a few of the services. And actually, interestingly, the person which wrote our PowerShell tools is the same person, Steve, which wrote the Visual Studio plugin. He did this as a hobby project, the Visual Studio Code plugin. And he did it as a hobby project last year, in part of his sort of research time. And now it's actually in developer preview. You can download it from the Visual Studio Code marketplace, and you can start using it. We also do have some higher level SDKs for developers. So this is our primary .NET SDK, toolkit for .NET. It's the AWS toolkit for Visual Studio. And unlike the one for Visual Studio Code, this is it has everything, all the services that you'd need directly from within Visual Studio. I won't go into this in very much detail, but basically you have a little view pane called the AWS Explorer on the right-hand side. And from there, you can create infrastructure, you can deploy applications, you can right-click a project and deploy, you can create users, you can add S3 buckets, you can upload images, you can create API gateways, lambdas, anything you want from within Visual Studio. So we're trying to, at AWS, always meet people where they are. If you're a Bash person with a CLI, then we have that covered. If you're a Visual Studio person, we have that covered. If you're a Visual Studio Code person, we have that covered. In 2012, when we were looking at all the different operations people and developers, they spotted a hole in the market for AWS, which was PowerShell. And there was a lot of people which wanted or were requesting PowerShell or a way to use PowerShell with AWS. And so in 2012, we released a module with a number of commandlets in there, which allow you to operate and manage and create AWS infrastructure from within PowerShell. And it started off as a very sort of simple project. It didn't really cover all of the various services, and it covered most of the services, but not necessarily all of them. And now we're at a point where AWS has grown substantially, and the PowerShell tools have grown substantially. There's a full-time team working on this now and evolving it, and we've got really good support across all of the different services inside of AWS. If there's a service inside of AWS, there's probably a PowerShell commandlet to use or create or delete or remove that infrastructure. Technically, the PowerShell tools or tooling sits on top of our .NET SDK. So you can actually, the .NET SDK is the oldest of our SDKs. It's the first SDK that we built at AWS. For any developers. So the .NET one is very mature. It has pretty much covers every part of our service offering, all 165 services and all the different features in those 165 services. And then the PowerShell calls into that. We actually generate a lot of the code for the PowerShell tooling directly from the .NET SDK. So we use we look at the APIs and the API coverage, and we do a lot of code generation to create the tooling. But what that means is that if you can do it inside the .NET SDK, then you can do it inside of the PowerShell tooling as well. There'll be a way of doing it. There'll be some kind of mechanism. So the first PowerShell module is called AWS PowerShell. It was released December 5th, 2012. We added to the PowerShell gallery in 2015. And this is what we've been pre-installing on EC2 instances on Windows instance types. So if you create a Windows instance type, we'll have PowerShell there, and we'll install our PowerShell tooling on some of those instance types as well. So obviously you can download it and install it on your local box, but if you create a Windows instance in AWS, the tooling will already be installed on those instances as well. Version 1 in 2012, I said it started off quite small in that it had 550 commandlets across 20 or so AWS services. Since 2012, AWS has grown massively, the amount of services we've added. Now we have, in version 3.3, which was this is actually an older version, in April 28, 2019, we have 5,510 PowerShell commandlets in that one module across 160 services. You might be thinking that's quite a lot of commandlets to have in a single module, and the team recognize that that's the case, and they're working on ways in which to split those modules up, and there's an ongoing work at the moment to try and make them maybe smaller modules rather than having it in one huge module. And that's having that many commandlets in one single module has caused a number of different problems over the years. I think there was some kind of breaking change that we were the first company to realize that there's an upper limit of how many commandlets you can have in a PowerShell module. If you want to publish it on the gallery, I think it's 4,000. So we broke the gallery for a little time when we went above 4,000. And yeah, so we're learning a lot. The team which works on these tools are PowerShell people through and through. Steve and the team which work on this want to get the AWS tooling so it works the way that the PowerShell community expect it to. And we're really open for feedback. If you use this stuff and you like it or don't like it, we'd really like to know about it. The tools aren't open source at the moment, but we do maintain all of the issues on GitHub. We will try and make it open source. Some of the portions, like the Lambda sections, are open source, but there's some work to be done before we can make it fully open source. But that is an ongoing task as well. We also have AWS Tools for PowerShell Core 6, and it's a module named AWS PowerShell.net Core. We announced this in 2016, August 2016. We're actually a launch partner with Microsoft. There's a smiley on that slide because Steve was really happy that he went on Channel 9 and presented the AWS tooling with Jeffrey Snover, and it was like a little career highlight for him, and that was cool. Yeah, it's been launched since 2016, and it has and maintains 100% compatibility with the toolkit for Windows PowerShell, so the old module, and it targets PowerShell standard now as well. They're obviously working to a point where they would probably like just have one module and support one module, but they do take backwards compatibility very seriously, and so there are reasons why they're maintaining both of those modules, as you understand. And so, but there are two modules, one for core, one for one which is the version which is the original version. In the GitHub repo that I share later, all of the code that I'll show today is in that GitHub repo. And there's a commandlet which we use to generate this graph, which is just the number of commandlets in the module over time. So on the left-hand side, that's the number of commandlets in the module, and then on this way, that's the number of well, the time. So you'll note that the graph goes up, 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 up. But you'll see these little spikes here. Those spikes are usually because we have a conference every year called AWS reInvent, where we launch a load of services. And so those little spikes are where, oomph, we have these little pops of services which all get launched at the same sort of time. It's in I think this one's going to be in December at the end of the year, so there'll probably be another spike. But you can see we're constantly adding new services to our PowerShell tooling over time, and we've had a commitment to do that all the way back to 2012, and we're constantly evolving this tooling as well. Based upon some feedback that we've received from the community in 2017, we did a big job of renaming our commandlets and parameter names to be more in keeping with what PowerShell people expect. Trying to make sure we adopt the standards of the PowerShell community, and we're constantly trying to improve that. There are places where you'll look at the way that we're doing things, and it doesn't feel very PowerShell-y. It feels like we're doing it wrong. Most of those instances, there's a reason, a heritage reason or a backwards compatibility reason we're doing it that way. But we do really encourage you to come forward if there's things that we're doing in a different way. If it doesn't pipe the way that you expect it to pipe or whatnot, then please do let us know, because we'd love to try and improve those sorts of things. In March 2018, there was lots of stuff happened last year in 2018. There was a big release of lots of the PowerShell stuff. So we put on our EC2 AMIs. AMIs are Amazon Machine Images. I think that's what it stands for. Weirdly, you'll hear people refer to that as AMIs. EC2 AMIs. I don't know why they pronounce it AMIs, but some people do, and they swear that that's what it's called. Lots of people at Amazon call them AMIs. It's clearly AMIs, but they do. So EC2 AMIs with PowerShell Core installed by default on Amazon Linux 2 and Ubuntu. We've added Code Build, which is our build pipeline tools. We've added PowerShell support there inside of the .NET Core Docker images, so that you can use PowerShell in your builds. Oops. We've added PowerShell support for Lambda. So our serverless platform was launched in 2015, I think, something right around there. It's called AWS Lambda. It's a way of building serverless compute. And when it came out, the original sort of versions of it were very basic, I guess. You could build stuff in Node, you could build stuff in Python, I think. And then we gradually added support for C#. And then over the next couple of years, we've added lots more language support. C# is one of the fastest runtimes in Lambda. It's actually the fastest runtime in Lambda. It's faster than Node. And PowerShell builds on top of the .NET Core Lambda runtime. So we do some work. Effectively, Lambda thinks that it's running a C# Lambda, but we're doing some work to enable you to run PowerShell scripts on top of that. And so we added this support, this first-class support for PowerShell inside of AWS Lambda, so you can create serverless functions in PowerShell. Now, as a developer, when I'm building applications, serverless is really powerful because I can create I can basically replace a lot of my APIs. I don't have to have containers necessarily anymore. I can break down monoliths into microservices and host them in Lambda functions. And the cool thing is I only ever pay for the compute when it's being executed. If my function is not being called, I don't pay any money or it doesn't cost anything. And so it's a really good, there's a charity in the UK called Comic Relief. They're the biggest charity in the UK, and one night a year they take over TV and they do this massive charity, sort of try to get money out of people for this charity. And they have comedians, world-class comedians on, and they just take millions of pounds. I think 20 million was the last number, and they'll take that like in one single night. And they adopted a serverless platform for their application, and they reduced their hosting costs for that application by 93%. So it was costing them $85,000 a month to run their infrastructure. They reduced their costs to $5,000 a month to run their infrastructure. So it's quite cool the way that companies are using it to build infrastructure and applications in new ways. But it's also interesting if you're trying to think about running services on like schedules or tasks when certain things or events happen in your infrastructure. So when things are put in an S3 bucket, or when logs are recorded, or when you get an event from a certain part of your infrastructure, being able to execute some code arbitrarily is actually quite interesting, not just for developers, but also for operations, so for being able to do things. And we're seeing a lot of people starting to use the PowerShell Lambda support to instrument and create these little functions which do things on demand when certain events arise inside of their infrastructure. And so it's cool. We've also been doing a lot of work on trying to add PowerShell code samples. There's a lot of good work going on in the tool level for PowerShell, but we're not always documenting that as well as we could. I've been hired as the .NET guy to do .NET stuff and make sure that that's really good. Steve is in charge of, he's now moved over to evangelism as well, and he's looking after .NET and PowerShell. So we're as a team trying to make sure that we have as many PowerShell examples as we do other languages for all the different services. At the moment, it can sometimes be quite hard to find some good documentation on the PowerShell, specifically when it comes to edge cases and things like that. So we're working on trying to improve that, and we've got a whole evangelism team which is trying to improve that. So on a Windows box, to install the AWS tools for PowerShell, we're going to basically install on that box the AWS SDK for .NET, and along with that, we're going to be getting all the sort of .NET stuff and also the PowerShell tools as well. It comes in an MSI, or you can install it however you want manually as well. To install the module, it's called, this is the .NET Core version, so install AWS PowerShell.NET. The .NET Core version, I keep calling it the .NET Core version. So old habits die hard. The PowerShell .NET Core version. And in the demos that I'll be running today, this is basically the command that I run just to make sure that I have the PowerShell module installed before I run any of my scripts. For the most part, it never really matters which version you're using. I usually am doing PowerShell stuff on my Mac, so I'll be obviously using the .NET Core version. But both will work interchangeably. Certainly, I think all of the demos that I'll be showing today, it will all work on both. So if we want to do something really basic, S3 bucket, simple storage service, SSS. So it's S3, simple storage service. I didn't know that when I joined AWS, why it was called S3. It never made any sense to me. And it just means that there's 3 S's, simple storage service. So S3 is the most popular service in AWS by a country mile. It's used for everything. It's for storing documents on websites, applications, and whatnot. And there's a concept of a bucket. And in this bucket, you can upload files or data or videos or whatnot to these buckets. It's one of the very first services in AWS, not the first, but one of the first. And it's really popular. And it's usually the first example that you'll ever see when someone wants to create something in AWS. I'll show you how to create an S3 bucket. And this is how we would create an S3 bucket. So I mentioned earlier that in AWS, you have to decide on the region. There are certain things called global services, but generally most services reside within a region. So there's US East 1, which is Virginia, I think. And that's the region. We set default AWS region as that region. And what that means is then in all subsequent PowerShell commands, it's going to be executing against that region. Most of the commandlets will accept parameters to override the region you're deploying to, but you can set up a global region that way. We're then just providing a variable with the bucket name, so PowerShell Summit 2009-Beeby US East 1. The reason I'm adding Beeby in there is because I want it to be unique. S3 bucket names have to be unique within a region. So if I just use PowerShell Summit, that would be probably taken. So you've got to be very careful about making sure it's unique. And then to create a bucket, there's a commandlet, new S3 bucket. I give it a bucket name, and it responds saying that it's created a bucket. So all I have to do, I will then be able to go onto the console if I want to, and I'll see that there's a bucket there. I can upload files via the console. I can obviously upload files from the command line, from PowerShell as well. If I wanted to create a few buckets, just doing a for each over the same thing, it's the same sort of principle. I take the bucket names and I just do a for each over that, passing it into the commandlet new S3 bucket, and create a new 3 buckets in this instance. So, inside the module, there's 5,000 plus commandlets. They all map to AWS Service APIs. So, under the hood, it's just calling our SDK, our .NET SDKs. We do though wrap. It's not always a one-to-one call. Like you're not making calls to a REST API. It's not a wrapper over REST. So, for example, let's say you're using the write S3 object in PowerShell. Under the hood, what that's doing is taking an image locally, maybe, and then it's going to post it to a bucket. Now, if it's a small enough image, I think under 5 megs, obviously it's just going to take that and post it to the image. However, if it's a larger file, maybe it's a gig, or I don't know, it's a much bigger file, 500 megs, something like that. We have a transfer manager in the SDK, which is able to, chunk that file up and then, pass the file over in blocks and do that all in a fault-tolerant way, a most efficient way. So you as a PowerShell developer or sort of operator would just write S3 object. Under the hood, the PowerShell is making a decision as to how it's going to connect all of that stuff. So is it going to use the transfer manager? How is it going to pass that large bucket, that file over? But you don't have to worry about it. You can just pass a massive file over and it'll work. But under the hood, it's doing some clever stuff with their interaction with the SDK to add those supports. So it's not always a direct relationship to our APIs. There's often we're combining different APIs together in the commandlets to give you a more reasonable experience. But the commandlets sit atop the public AWS SDK for .NET. And what's important to take away from that point is that everything that you can do inside of the .NET SDK, you can do somehow inside of a PowerShell SDK. And because often you're running on machines with .NET Core, you can even, in your .NET, you could even use .NET code if you want and drop out. And I often will do that to deploy things occasionally, maybe because I don't know how to do it in PowerShell, and I do know how to do it in .NET. So this is an example of a VPC. A VPC in AWS is a virtual private cloud. It's like your little piece of infrastructure, like your little box around your cloud. And you can have you can set up the VPCs in many different ways. You could have them with multiple subnets. You can have them connected to the internet or disconnected from the internet. You can have, it's networking. And to deploy a VPC, you could write it all of the different objects. You could go through it and write it all in PowerShell. But it would probably take a long time. And also, those scripts have become really, really complicated. So what most people do is they use some kind of infrastructure as code system, maybe Ansible or Terraform, or in the AWS world, we have one called CloudFormation. And that is like a YAML or JSON document which describes infrastructure. So in this GitHub repository, I have a VPC YAML. You'll see over here. You see there's a template, vpc.yaml. That YAML file contains all of the complication of how to actually configure and set up my VPC. And what's cool about that is that if I just deploy that piece of YAML to CloudFormation, CloudFormation will take that YAML and construct my VPC for me, and it will be identical every single time. That's what CloudFormation is inside of AWS. So I create a stack. We call them stacks, which are like, and we give it a name, so this is called VPC. I want to know what zones are available inside of a specific region. So I call a commandlet get EC2 availability zones in the region or the default region. So if I'm in EU West 1, it's going to come back with all the different names of the EC2 availability zones. Availability zone 1, 2, 3, whatever. And then I just take the zone name. So there'll probably be, in most regions, there'll be 3 of these things. And then I select the top 2 and join them together with a comma. So now I've got a string which contains 2 of those. And then that's actually the parameter that I'm going to pass in to .NET Lambda deploy, and this is going to deploy that YAML file in that particular region. It's going to upload that YAML file to an S3 bucket, and then it's going to pass the parameter availability zones in there as well. So I'm kind of combining some .NET and some PowerShell in that one script. And that just shows you can mix and match a little. So that's a commandlet getting the availability zones, and then I'm passing that in to create my VPC. And this is the VPC that I use in this demo, or all the demos subsequently. If I want to create some machines and some instances inside of that cloud, inside of that VPC, I could go up and I could create them manually, or I could go in there and deploy an EC2 fleet. So I've got another YAML file, CloudFormation YAML file, which describes how I'm going to build that infrastructure. And that will then create my instances for me. This is what a CloudFormation script looks like. I'm not going to go into this, but it's all in the folder. Now, so you can see you can use PowerShell. You can start creating infrastructure. You can combine it with things like CloudFormation to create more complicated systems. We can deploy infrastructure as code and those sorts of things. But then what about if we want to manage the actual instances that we create? What we want to run commands on them all. Or we... 5 minutes. So it finishes at 1:15. That's 20 minutes. 1:45 to 1:45. Okay. So AWS System Manager is a system which allows you to control all of the different instances and virtual machines. Sorry. Inside of AWS. And so it's like I hate this word, but a single pane of glass to give you visibility and control of your infrastructure. Every vendor in the world's got a single pane of glass, haven't they? But this kind of allows you to control your different instances inside of your VPCs. And it supports EC2 instances, or these virtual machines, in the cloud, or you can also manage on-premise systems through this system as well. And the idea is that you're able to manage and operate your different EC2 instances at scale. And the PowerShell team have worked hard to try and make sure that some PowerShell features are in here, so it makes it feel more sort of a more PowerShell feel when you're managing your infrastructure. So let's have a look. So just to quickly, if you're wanting to know how you get to, we've got 5,000 commandlets in a module. It's quite difficult to find out what commandlet to use. There is a convention that they use in the team. Across our APIs, there is an operation called, let's say there's an operation called describe instances. Now, get describe instances The problem with having that is that you'll see that 3 of our APIs on AWS actually have an operation called describe instances. So we couldn't just call it get instances. So what they've done is they prefix the noun with the service. So get EC2 instance, which would be describe instances. And so you can run this command shell, which is get AWS commandlet, API operations, describe instances, and it will show you all of the different services or commandlets which have an operation called describe instances and the service that it runs in. So this is the way that we navigate the AWS commandlets and find out what's in them. Also, get -AWS PowerShell version list services will list all of the different services that you can access or operate on in PowerShell, and it will give you the noun prefix that we prefix things with, so the different services that we use. And we can do the get AWS commandlet name -service, and we can search for the service, which is System Manager, and it will show us all of the commandlets for System Manager. So we can explore that and find the System Manager commandlets that we could use and operate with. So there is a number of things you can do with PowerShell, with System Managers. We can do a run command, which is we can basically run commands arbitrarily on a fleet of machines. Arbitrarily. We code tasks that we can run on different machines. State Manager, which is automating configurations to keep systems in a defined state. We have Session Manager, which is a way that we can get access to our instances without ever having to open up the ports on those machines. So we didn't need to open up any firewall ports on any of those instances. Just over port 433 outbound, we have a way of being able to connect you into those instances and run PowerShell on those instances. And we have compliance inventory allowing you to publish and store the compliance data that you might need to. And so let's have a look at a couple of these. So I'll just show you. Parameter store first. So parameter store allows you to store information in our parameter storage system inside of System Manager. So it's a way of like key value pairs inside of a parameter store. So here we have a commandlet called write SSM parameter. Now, System Manager, it's System Manager, so you'd expect it to be called write System Manager parameter, but it's called SSM because the service used to be called Simple Service Systems Manager or something like that before. And we basically name our commandlets with the first name the service was ever given. So you can search for System Managers with those other commandlets and find these commandlets, but you will find sometimes that we've subsequently changed the name of a feature, and the commandlet's still using the old name. And we maintain that because we don't want to add new commandlets just to alias old commandlets. And we also don't want to have backwards compatibility issues with people which might have implemented old commandlets in their scripts, and then we would have to replace them just because we've changed the name. So you will see this is one service which we've actually renamed 3 times. So I'm just taking this parameter. So I'm giving it a value, which I'm going to store as my parameter value. And I'm going to be using a directory kind of storage. So I can say my service production configuration value, and this is the actual value. The reason why we are doing it like this is that it means that we can actually query. I could just query my service production and get all of the configuration values for that particular application. And so you can slice and dice this however you wish to. If you have multiple applications with different production test or whatnot, you might have different values for all of those different things. And so you can query my service in production and get all the config values, or you can query my service in development and get all the config values. So I will just write that value, and you'll see it returns a 1. That means that's version 1 of that parameter is stored in that parameter store. And so my service production config value -1 will have that value in. If I edited that value and then added it again, it would return 2, and then it would store the old value, but you would now get a 2 number, so that accesses that parameter store value. So if I run that one, you can have different types as well. So I put one in production and I put one in test there. And so if I query my service test, I would get config value of this. And if I put my service in production, I will get this production value back. And they're both types of string. We've got an overwrite set to true. Obviously, automatically it will overwrite. It won't overwrite a value if it already exists, but if we set that to true, it will. I can also do a secure string, and what secure string does is it encrypts the parameter on the other side. So if I go and call and add that parameter to my parameter store inside of Service System Manager, add it, and I add another secure one for test. You can also take any object, convert it into use JSON to convert it into a string and store it in parameter store. So you can have a way of storing more complicated objects. It doesn't have to be just string values, obviously. And that would be an example of doing that. And then we can retrieve it. So here I've got get SSM parameters by path. And I'm saying I want to go for the my service production and pass all the values back. So you'll see that I've got two values in production, config and secret code. The config value has the value in clear text. The secret code, because it's a type secure string, the value is obfuscated. It's not the same value as we put in a moment ago. We're actually using default encryption. There's a key pair on your AWS account. You can configure all of that to use your own encryption keys and things like that, but there's a default one installed already, which we're using. I can get a single parameter from that parameter store. See, that's a production parameter, so I just get the prod 123 back. I can have the multiple parameters from the production account. So I've got prod and my secret code. And I can also choose to decrypt them. And so if I pass in, and you'll note that I'm piping these different commandlets as well. Whilst we are using code generation, I've done a lot of work to make sure that you can pipe our commandlets in the way you'd expect to be able to. So with this one, we get all of the parameters, and then we use get SSM parameter value with decryption true. And what should happen is when I run that, I should get my values back, but instead of being decrypted this time, my secret code is now decrypted. And yeah, I can remove those parameters as well. So that's parameter store. We also have a system called Secrets Manager. This is a similar service. Parameter stores are meant to be for any kinds of parameters in applications or configurations and stuff like that. We also have Secrets Manager, which is a different service. No, where's it gone? That's not run command. Secrets Manager, that's what I want. So here I have just run that piece of code, and secret name posh. There's a commandlet called secRandomPassword, which is quite handy actually to generate sort of a random password string. So if I do that, create that there, and respond back out, you'll see it just creates a random string with those characters excluded. I can create a new secret. It's a bit like a parameter store, but it's using this secret service, new secret, SCS secret, and I will run that one to create that file. And then I can retrieve it in a very similar way to the way that you can see the parameters were done before. I can update that secret. You'll get this thing called an ARN. This is quite common in AWS, an ARN. It's like a URL to a resource. And you'll see it all the time when you're creating instances or instance types, you'll have these ARN descriptors. That basically points to that piece of infrastructure, that secret. So if you ever see an ARN, that's what those are. I can retrieve that value, my new secret value, and finally I can remove that secret if I wish as well, and use the force to just remove that as well. I can wrap these higher level functions or these commandlets in my private commandlet. So I've got this save credentials. It does a little bit more, and what this allows us to do is create a more PowerShell-like experience. So I'm just going to just run this to get it in memory, and then use those wrapper functions. So I can use getCredential to create a PowerShell credential. I don't think I need to run those, but I will anyway. To create a new credential, so I'll create a new PowerShell credential, user Beeby, password Jeff, and then save that. PowerShell, that credential which has been created by PowerShell, it's going to be using my wrapper function, which is wrapping the PowerShell commandlets, so I can save that as well. So it just gives me a little bit more of a, I can now interact directly with different types of objects as well. And I can retrieve the secret. And finally remove the secret. So that is what the parameter store and secret manager store are, and how you can store secret values or parameter values inside AWS Systems Manager. If I go to Systems Manager, here. You'll see that I've got AWS Systems Manager, and there's a thing called Session Manager here. And I'm going to start a session on Session Manager. And now the infrastructure that I created earlier before the session using that CloudFormation template, it generated 2 instances, and one of those instances, or 2 of those instances, have names. They're in 2 different availability zones. One's in US East 1A, and one's in US East 1B. And the instance name is DSC demo. So what I can do is go in there, create start session. There's no open ports on that machine. It's not exposed to the internet, but now I have a PowerShell command line directly into that machine. There's no open ports now. I'm managing it all through Systems Manager, which means that you don't have to have a jump box to do anything like this. You can just directly connect via Session Manager. So it's quite a cool way of sort of gaining access to some of these different PS. And you get sort of full support of PS. All the sort of tab completion and stuff that you'd expect inside of PowerShell, but it's obviously running through this system. So that's what Session Manager means. So if I refer to that, then that's what that actually means. So I've got 5 minutes left. We also support DSC with System Manager, and we launched this in 2018. And we have a commandlet called AWS apply DSC moths. And what you do is you can take a moth file and execute it against System Manager, and it will run it on the instances that you ask it to be run on, and then it would be configured in the way you expect it. So this is our own thing. The parsing of the moth file is something we're doing internally. We're not using the local, what's it called? Thank you. We're not using the local configuration manager on the nodes. We're actually managing that ourselves. But the idea is that you could be able to take a moth file, deploy it to an AWS instance, and then all that configuration should happen. So let's have a look if we can see that. In slideshow. So hello world. So I'll just run those things on this file. So if we went over to Session Manager and we checked those machines and we ran oh, crap. I forgot to delete it, didn't I? Oh, no. Okay. This actually is in the desired state. I should have actually removed that previously. Let me... Oh, I wonder if I've got a clear up routing. F8. Oh, damn. That won't work because the association. I can do it for the console. Okay, it's actually not going to work, I'm afraid. Sorry. I'll try and just talk over the code just briefly, just to explain what it's doing, and I'll put a demo out of this working in. What I was hopefully showing you there was when I ran that, you should have seen on those instances there wasn't users, and there wasn't a file on the object path. That was the point. And what we were going to be doing in this file is we're creating a local user in PowerShell. And then we were adding that PowerShell user to we're going to create a secret in Secrets Manager. And then we were going to add that to Secrets Manager. And then we have a desired state configuration file, configuration TCS demo. And this describes the state of the machine that we want to, the state we want to get that machine to. And the state we want to have is the user installed and a file local on disk. And so this is the code that you would go to create your MOF file effectively. I'm just going to run all of this code. And what this code will do is it creates the sort of the file, the state of the file, the thing that we need, and then we from the command line as well we can create the MOF file. It should produce the MOF file. It's running. Oh. You're quite right. So did it generate the MOF file? It did. And then I write that MOF file to the generated MOF file to S3, sorry. We'll create an association inside of Systems Manager. And then we'll create a new association inside the Systems Manager. And it basically explains where this association has parameters like where the MOF file is, what it's going to do with the MOF file, is it going to deploy it, are we going to reboot after we've deployed the MOF file, and various different things. We will execute that code. It should upload that MOF file. Systems Manager should then take that MOF file, go to all of the connected instances. It's looking for all of the instances with DSC demo. It's going to find all those instances. It's going to deploy the user and the file to all those different file things. And then if we went back to the sys file, the Systems Manager, and we ran the code about getting the user will be there. But we know it was there before because actually it was a mistake. Anyway, sorry about that. A massive demo failure. That was the same demo which failed for Steve, but he recovered it slightly better than me. I apologize for messing it up a bit. One thing I was going to show you, I've got a session on later in the week, is actually how we build PowerShell functions and how we use PowerShell and Lambda. I actually have a session later on Thursday. So if you're interested in how you do PowerShell and Lambda, then please do come and take a look at that. I will just quickly... I'll take your question in just a second. There's some GitHub links. If you want to know what the AWS tools for PowerShell are, there's a GitHub link over to there. That's where it's not open source, but you can store issues. If you've got any issues with it there, we do maintain a list of issues there. The Lambda tooling for .NET Core and PowerShell are open source, and they're on GitHub. We have links to our packages on the PowerShell gallery, and we have an AWS developer blog, which now has lots more .NET and PowerShell content. Sorry, you had a question. You can do that through Systems Manager. If you want to come up now, I've run out of time, but if you want to come up, I'll show you on the console. Thank you very much. I'm sorry about that last demo failure. It kind of flew me a little bit. If you do think the session was good, though, please do use that button and press it. You can press it like that. I'll probably need some help to make this session half decent, I'm afraid. Thank you very much.